Here I am going to explain you my YOLO V8 OpenCV Python project for object detection using MLAI. I have made also many projects in that domain, but I am going to explain you this. It is a basic project, but it take a lot of time to train. So I decided to share it to you all. First of all, we are going to download the dataset because the dataset is the main thing on which you are going to train the model. If you don't have a dataset, you are not able to train a model. So first of all, I am going to download the dataset. I have downloaded that dataset from Kaggle directly as named CCTV surveillance dataset. This dataset contain about 20,000 images on which we are going to train our model. And now we have directly the link. I will also attach the link of the dataset in the description. You can download the dataset from that. In this cell, we are simply downloading the dataset and upload it to the Jupyter notebook, as it is easy to access Kaggle dataset to the Jupyter notebooks. In the second cell, we use pip command to install needed libraries such as Ultralytics, Torch Vision, OpenCV, Python, Matplotlib, and Pillow. All of these libraries would use in our project. For example, for image processing part, we will use Pillow, OpenCV, Python for the object detection, Torch Vision for the dating, saving the train model. In this set, we import that libraries we have downloaded above in above cell. Import Torch, import from Ultralytics, import YOLO. As we have two basically two libraries to access object detection. One is YOLO and there is SSD. I prefer YOLO because it is versatile. YOLO, NumPy, Pill, import image, and import OS. In the next cell, we load the YAML file. Where YAML file is basically a file in which our model is going to be saved, which means that all of the files of the our code or model will be saved in that YAML file in YAML format. So it is simple to load that. In next cell, we are going to giving the attributes in the train model, like that attributes which we are gonna to search in our object detection or an image after the training. In next cell, we save the configuration model type in our model. So we are going to train this. In 28, now finally we are going to train our model on the given attributes we mentioned in the above cells. As we have start the training, we are going to make that training which became 100%. This specimen 100% sees that to train our model. As you see that 100% giving. For instance, I am going to mention that I have trained this model on my previous PC and save all the results to explain you what the result will be given after training. This 100% give you that the dataset have been loaded successfully. Now, these are the main things which we are going to see in our training models. The Jupyter notebook and the libraries we used in it divided the total images of 20,000 into 30 parts to make a good training model. Here you see epoch 1 by 30. Epoch means that one subpart of all that 20,000 images. In this, there are 3, 4, 5, 6 images. Instant is 4 to 5, 9, and its efficiency was 0.0819. Means 0.8%. Furtherly, one part of training takes about 59 minutes to complete. As we have the 30 parts, so it will take approximately about 30 hours to complete. Now, this time of training depends upon the requirements of your PC, your GPU, your processor. As I trained it in my previous PC, it wasn't made for these image processing models, so it takes 30,000. In your laptop or in your PC, it would take around 14 to 15 hours to complete the training, and rest of the thing will be remain same, about 30 subparts. As we see that all training completes in parts in around averaging time of 55 minutes. And here you see that 30 epochs completed in 30.770 hours, as I mentioned earlier. Optimizer step. Now this showing that our model is trained 100% now. Now we are going to test our model by giving it an image, and it will detect an object in the form of person in that image. In this cell, we make a run inference function that will run through all the model, and this function plot detection use OpenCV to detect the objects in that images. In the above cell, in this cell, we only trained the model on all the 20,000 images, but in this cell, that is definition of plot detection function, this will move through all the trained images and detect the object from that. And in next, we are going to test our image. Test image, we have stored the address of test image in a variable and pass this variable to run an interference function, and plot detection will predict our images. As the plot detection function arguments are image path and result, image path is saved in test image and result is saved in the run inference, which I mentioned earlier that it will run around all the images that have been trained in the model. See, here is the result after the model prediction, as it is giving not a very nice efficiency because I have trained it only one time. Obviously, if you train it more and more and more, about 10 to 20 times, it will give you maximum efficiency. It will give you maximum efficiency. And here we have saved the trained model in the TOScript form because we cannot save it in JPG format, IPYNB format, Python file format. So we are going to TOScript format, and these all folders according to that code file will remain in our YAML folder that we initialize here, in this cell. So this is what my code of object detection using YOLO V8 OpenCV in Python. Hope you understand. If you have any question regarding this code, you can ask in the comment section. And I am also attaching the link of the dataset in the description. You can download the dataset from that link also. Okay, see ya. Bye-bye.